Hello everyone, this is Sumerian, and in today's tutorial we're going to be covering greater than, equal to, or less than functions. I've decided in the next few tutorials at least, I'm going to look at the Creativitoys and at problems from a programmer's perspective as opposed to the way I usually do, which is from an electronics perspective. There's probably a lot more people out there more familiar with programming terms, and so we're going to just look at them from a programmer's point of view for at least the next few tutorials. Now, some of you who have watched some of my other tutorials might recognize that this is from our last tutorial. This is the currency toy box that I have up. And I have it up for a couple of reasons. The first reason is because if you really think about it, the currency system that we set up here is basically doing a greater than or equal to and a less than function to find out whether we have enough currency to activate the different logic chains. But the second reason I brought it up, and it's slightly with a heavy heart, I have to admit this, is that I went back and I looked at this logic circuit and I realized that I have overcomplicated it. This system is, it works, but it's a little silly now that I look at it twice. The only defense I have is that I was, like I said before, working on a few different systems to try and get this currency to work, and they kept running into problems, and I had to put in more logic to try and fix the problems. So by the time I arrived at this solution, the 5 logic pieces here were simple and elegant compared to some of the other solutions I'd come up with. However, it's still far too complicated. With these 5 pieces here, we can do the exact same thing with only 3 pieces of logic. And so we're going to actually fix that right now. These 2 logic gates that are doing the odd flip-flop thing are completely and utterly useless. I take them out, and I'm going to show you how we accomplish the exact same thing. So, this logic gate, or this counter, should be set to the number 4, which is our target count of 5 minus 1. And this one is set to our target count of 5. So what we're trying to say here is if the player has 5 or more, or is equal to 5 or greater, then they can purchase these items. Well, if they're less than 5, they cannot purchase the items. So all we really have to do here is this counter is set to 4, and we'll think about it from the beginning. So we start at a count of 0, and we count up 1, 2, 3, 4. Target reached, and this guy will fire a target reach message. Well, from the very beginning, default, all these logic gates are open, and we have nothing hooked up to their outputs. They only do something when they're closed or input blocked. So there is absolutely no negative reaction to me saying target reached of 4 opens this logic gate. It's already open, and opening it again is not going to change anything. And then I say, okay, I've hit 4. Now my count goes up and it hits 5. I now have at least 5 coins. So now the user is able to step on these triggers and purchase items. So when my target reaches 5, I can close these logic gates. And then we'll go in the reverse order when we're thinking about it. We'll say we're at about 7, and we subtract 5 after stepping on this. Well, the count will go 7, 6, 5. When it hits 5, it will trigger this, which will close this logic gate, which is already closed. So there's no difference whatsoever. But then we hit 4, and this counter triggers, and it will open this logic gate, now saying you do not have enough to purchase. And then we hit 3 and 2, and we are set to the open state where the user cannot purchase the item again. So by simply removing those 2 logic gates and just tying the target reached of the counter that is the currency value you want, and in this case I believe it's 15, we'll double check that. Yeah. So at 15 we want to close this logic gate, and at 14, which is 15 minus 1, or less than 15, we want to open this logic gate again. And that has actually taken our 5-piece logic and turned it into 3-piece logic. And I'm sorry about before, I must have been tired. Well, that's my excuse, I'm sticking to it. So there, we have now fixed this logic so that instead of the 5 pieces, it's 3 pieces. And what we've accomplished here is a greater than, less than statement. It's just 3 pieces of logic. Now, let's just double check that this is working. Drop down. I can jump on this trigger again all I want. Nothing's going to happen. I push this button, which will bring me up to the count of 4. And all 4 is doing is reopening that logic gate, so nothing is going to happen until I pass the count of 5. Now that I've passed the count of 5, I can purchase the item again. Now the important thing to remember, for this logic to work, we have to have these increment systems in where the count is only changed by 1 at a time. And there's actually 2 reasons for that in this logic. The first reason is because when you're adding numbers to these counters, as I've said before in another tutorial, is that when you're going up in numbers, even if you skip this number, so say we're at the number 3, and we push this button, and we just add 3 to both these counters to get to the number 6, even though you haven't actually hit their individual value, if you go over their value, the target reached will still fire the 1 time. Now the problem is, if I go directly from 3 to 6, both 4 and 5 will fire at almost exactly the same time. And then it suddenly becomes a Russian roulette as to whether or not this logic gate is going to get the 5s close first or the 4s open first. So you've got a half and half chance of this logic not even working unless you increment the values 1 at a time. It's happening very quickly, but it's happening in such a way that 4 will get hit first, so we'll open this gate, and then milliseconds later 5 will hit its target reached, and it will successfully close the logic gate. Now the other reason you need this is because when we're subtracting numbers, the target reach doesn't work the same way. If you're at the number 6 and you subtract 3 from both these counters, neither of these target reached will fire going down. You have to hit the number directly when you're subtracting for the target reach to fire. So that's why we have to do it one unit at a time when you're going down as well. Alright, so we've now fixed this logic up. Have I done this? Yes. And I'm actually going to show you some other applications where a greater than or less than unit might be desirable. Skip this part. So right here, I'm going to add a small piece of terrain, and I am putting it down a little bit from the first terrain there for a reason. And what we're going to do is we're going to use a greater than less than statement to control how many enemies are up here. And the reason we might want to do that is I've seen a lot of toy boxes where the user appears to have a repeater going, and it just keeps spawning enemies after enemies after enemies. And after a while in that toy box, there are so many enemies running around that your game just starts to lag, and it lags bad. And you actually start to not like the game that you originally liked just because it's lagging so bad and it's starting to just act horrible. So we're going to put in a system here where we're going to have this area always have some enemies here, but we're going to control how many enemies it can have. And it's going to be designed for such a way that if you get rid of some of those enemies, it will bring them back, but only back to that number. And we're going to do that using the greater than less than function. So what I'm going to build here is I'm going to build just a simple enemy generator attached to that locator, and we're going to build a quick greater than less than equation. And how many enemies do we want here? We're going to say there'll be 6 enemies here, maximum. So we need 2 counters, and we need a logic gate. And we're going to set this counter to the value we want, which is 6. And we're going to set this one to 1 below that. So we're going to set this one to 5. And like I just showed you up there, we're going to say target reached closes this logic gate, and target reached opens this logic gate. So what we want is we want to keep spawning enemies until we have 6 of them. And as we just saw here, when we hit 6, this logic gate is going to close. So we're actually going to do the opposite of what we're doing with currency, where when it's closed, we don't want to spawn any more enemies. But when it's open, we will say out of the output, spawn another enemy. What should we put in there? Let's just put a Zergbot. We'll have 6 Zergbots wandering around there. And what we're going to set up here is we're going to put a repeater in. And this repeater is just going to fire us off some enemies until the count gets too high for it, and then it will won't allow, this logic gate won't allow any more enemies to be spawned. So we're going to set this repeater to 5 seconds works for me. Actually, we want it to go a little faster than that. Let's go 3 seconds. Now, we want to have these counters accurately tracking the how many enemies there are. So we're going to say, when an enemy is generated, increment by 1, and if the user destroys an enemy, we're going to say, okay, if an enemy is defeated, we're going to decrement by 1 each of these counters. And just because I don't want this repeater to just keep firing forever, I want to actually keep my logic so that there's not stuff running that doesn't have to be. I'm going to say, when this logic gate closes, when we've hit 6 enemies, turn off the repeater. But when it reopens, or we have less than 6 enemies, turn the repeater back on. And that's a nice clean system, and all I have to do is send a message to originally turn this repeater on, and we should have 6 enemies show up there, no more, no less. And I'm going to keep one of these counters displays on just so we can see how it's doing. So, I'm going to attach this button just to turn on this repeater. When I push this button, 6 enemies should spawn there. 1 every 3 seconds. And it should stop. There are now 6 enemies. I've defeated. And you're back to 6 enemies. And the repeater will turn back on and keep bringing us more enemies. Now if you want it to happen faster, you could just turn up the speed of that repeater to repopulate quicker. We'll do that. We'll set the speed to, let's go to the speed of 1. And there we go. We get back up to 6, and we have 6 enemies, no more, no less. So that is a great way to use the greater than, less than function. I'm sure you'll find a lot of other ways. There's always different ways to do everything in Divi Infinity. I look forward to seeing what you manage to create with it, and I hope this tutorial helped you out. Have a great day.